Imagine you and two other people are waiting for an elevator in the lobby of a building. When the elevator doors open, you see there are 20 people crammed into that tiny space. Who in their right mind would try and fit on that elevator? Not you. There are just too many people in there. The doors close and you wait for the next one. This is basically what happens when two solutions meet in biology. The two solutions compare their respective crowdedness to each other, and then each solution reacts accordingly. Sometimes one solution has more stuff crammed into it than the other. We call this stuff solute. The amount of solute in a solution determines how that solution will react when in the presence of another solution. A solution can be labeled one of three ways when it is compared to another solution. First, it may be considered an isotonic solution, meaning it has an equal amount of solute and water when compared to another solution. Second, it may be considered a hypertonic solution, meaning it has more solute and less water than another solution. Third, it may be considered a hypotonic solution, meaning it has less solute and more water than another solution. This is the situation described above when you were waiting in the lobby. You and the other two people were like solute in a solution, and all that space around was the water. When the elevator doors opened, there were a lot more people and a lot less space in that elevator, a lot more solute and a lot less water. Therefore, your lobby was considered hypotonic when compared to the crammed elevator. Notice the words I keep using: hypotonic, hypertonic, and isotonic. All three have the term tonic in common. What does that mean exactly? Well, tonic refers to the tonicity of a solution, or the osmotic pressure gradient of two solutions separated by a semi-permeable membrane. A semi-permeable membrane is a barrier that only allows certain molecules through. Things like water molecules can pass through the membrane easily, but things like salts or proteins or fats cannot. These membranes are very common in living things. In fact, every single one of your body cells is covered in a semi-permeable membrane, just so you have control over what goes in and out of your cells. Now, are your cells sitting in some dry desert all day long? Nope. Your cells are constantly bathed in a liquid in your body. They are constantly in contact with various solutions. So your cells are constantly comparing themselves to other solutions across a semi-permeable membrane. This is where tonicity comes in. Once again, tonicity is a measure of the osmotic pressure gradient of two solutions separated by a semi-permeable membrane. Osmotic pressure gradient is the amount of force needed to keep water from flowing across that membrane. Water likes things to be equal on either side of a membrane. It doesn't want one solution to have lots of solute while another has only a little. Therefore, water will rush across a semi-permeable membrane from areas of low solute concentration, high water concentration, to areas of high solute concentration, low water concentration. Basically, water wants to dilute that solute. Those solutes are what exert the osmotic pressure. Since solute cannot cross the semi-permeable membrane, the amount of solute in a solution determines if water is going to rush across that membrane or not. Therefore, solute concentration controls tonicity. Well, the relative tonicity of solutions is very important to the health of all cells. Let's think about your blood cells. You have these red blood cells that are extremely important to your body. They are basically little bags of proteins encased in a semi-permeable membrane and floating around in a watery solution in your veins. Hey, that sounds like a perfect setup for some tonicity, doesn't it? Yep, it is. The insides of your blood cells are a solution, and that solution is compared to whatever is on the outside of the blood cells. If the solute concentration outside the blood cells is less than what is inside, then what do you think is going to happen? Remember, water wants to rush across a membrane and dilute solute. Yep, you got it. Water from the surrounding solution will rush across the cell membrane and fill up the cell. This is called a hypotonic solution, in which the surrounding solution has more water and less solute than the cell. Can you imagine what would happen if your blood cells had to hang out in a hypotonic solution all day? They would burst. This is why you can't inject yourself with pure water. There aren't enough solutes in water, so you'd be forcing your blood cells into hypotonic solution, and that would cause all manner of problems. What do doctors put in that IV bag then? Saline. Saline has the exact same concentration of solutes in water as blood cells do, so the cells don't have to worry about water rushing across the membrane. Let's review. A hypotonic solution refers to when one solution has less solute than another. This situation causes water to travel across a semi-permeable membrane in order to try to dilute the concentrated solute.